Hello guys, I hope you're doing alright. Here we have a new video about sets. Okay, we continue with the topic that we started from last week, and today we're going to talk about the notation of a set and the complement of a set. So you can check the slides, the PowerPoint presentation from slides 12 to 15, and you will have the same information that I will explain you here. Okay, so first of all, we are going to talk about the notation of a set. So the first method is called the roster method, and the roster method of specifying a set consists of surrounding the collection of elements with braces. So how can we do this? For example, if we have a general description like this, whole numbers from 1 to 5, we could write this set with a roster method like this. So we can write a set A equals 1, 2, 3, 4, 5, because it includes whole numbers, remember the whole numbers, from 1 to 5. And here we have the example. Other example in roster method. What if we write a set B that includes even numbers from 4 to 11. So how can we write this set with roster method? So we can write B equals even numbers from 4 to 11. So we write 4, 6, 8, and 10. So we don't have more numbers. This is the roster method for this set. Now, remember that we can use ellipsis when the pattern is obvious and the set is large. So when we have, for example, other set from even numbers from 4 to 1001. So we could write 4, 6. We can use ellipsis because we have many numbers between, and then at the end, the last number, the last even number, is 1000. So this will be a set with ellipsis within roster method. Okay, so we have more example. B is the set of odd counting numbers or whole numbers is the same, less than or equal to 9007. So the odd whole numbers is 1, 3, 5, 7, ellipsis because we have many numbers between until 9007. Okay, so the next example we have C equals 1, 2, 3, ellipsis is the set of all counting numbers or all whole numbers. So we have 1, 2, 3 to infinite because we don't know the limit of this set. So ellipsis again. Okay, so from a pattern, from a description, we get the set. Okay, we list all the elements in roster method. But now, what happens with the second method is called set builder notation. And it has the general form, the variable, and a descriptive statement. Here we have an example. A set is, so we can read, remember, this is a key that we can use to describe these sets. The vertical bar in set builder notation is always read as such that, okay, so we have x such that, the bar here, x less than 6, and x is a natural number, is the set of all counting numbers less than 6. So this is the same as, this is the set builder, this part, all of these is the set builder because we have a description, x less than 6, and x is a natural number, okay, until this part. So this is the set builder. And how can we describe this set? X less than 6 and x is a natural number. So we have 1, the set S equals 1, 2, 3, 4, and 5. This is until less than 6. So let's see other example here. So we're going to write something like the set T equals the elements X such that X less than, for example, 15, and X is an odd number. So how can we write this set T? This is set builder. How can we write this in roster notation? In roster notation, we can write T equals, read the description again, X such as X less than 15 and X is an odd number, okay? So we write the odd numbers to 15. So we can write, for example, 1, 3, 5, 7, 9, 11, 13. Remember, this is less than 15, so we don't include 15 here because 15 is not less than 15, it's equals to 15. So the last number will be 13, okay? So we have the roster notation here, okay? So this is a good example. Other example, let's check again. So X is greater than 2 and X is less than 12 and X is a even number. So we have, this is the set builder. And how can we write this set in roster notation? So we can write the set T equals, and we list all the elements from 2, because less than, more than 2, and less than 12. And it should be an even number. So we cannot write 2 because this is not greater than 2. So we start by 4, okay, because greater than 2, 4, 6, 8, 10, and question, can we write 12? No, because we don't write the limit here because it's less than 12. So it doesn't include 12. So this is the last element. So here we have this example, okay? Okay, guys, let's go to the next part. Let's erase this, and let's go to the next slide. Here we have more examples. Okay, so write down the set B in roster notation. This is a little bit more complex, but let's see. X equals n squared and X is less than 30 and X is a natural number. Okay, we're not going to solve this because it's a little bit more advanced, but if you can find the right way to get this set, so congratulations, this is an advanced exercise. So let's go on with this example with the write in roster notation the set A. Okay, how can we write the set A in roster notation? So firstly, let's read the instruction here. So X such that X is a natural numbers, this N is a natural numbers, remember 1, 2, 3, 4, 5, and X is less than 12. So we start from the first natural numbers, that is 1, until 12. This is a new sign for you. This is less or equal to 12. So it includes number 12 because we have a little line here with the crocodile, with the alligator, and it includes number 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It also includes 12 because of this equal sign here below. Okay, so we close the set and we already have the set A. Let's continue with the set B. What do we have in set B? Let's read the description. This is set builder. All of this is set builder. Okay, this is set builder because we have all the descriptions. Now, let's continue with this. So here we have B. B. Y such that Y belongs, this sign is belongs to natural numbers, and Y is between 4 and 15. So the natural numbers between 4 and 15. How can we write it down? So from 4 and 15, so we start in 4. So 4, 5, 6, 7, 8, 9, 10, just natural numbers, 11, 12, 13, 14, and the last one, 15. It includes either 4 and 15. And we close the curly brackets, and this is the set B. Now, the next one, we have the set C. Okay, the set C, an element W such that W belongs to natural numbers, once again, and W is greater, this is the crocodile sign, greater than 28. So the numbers greater than 28, it doesn't have the equal below. It doesn't have the line here. So this is greater than 28 will be 29, 30, 31, 32, ellipsis. Okay, so we start 29, 30, 31. This is an infinite set because it doesn't say any limit. It doesn't say until what number do we count here. So we can write ellipsis here and we close the curly brackets. Or we can write even more numbers, 32, 33, all the numbers you want, and ellipsis, okay? Because this is an infinite set because it has ellipses, okay? And let's check the last example. The last example here. Here we have the set E. The set E, we have the elements X such that X belongs to natural numbers, once again natural numbers, and it's from, it includes, because we have the line here, it includes from 110 and 145. So we can start by 110, and we have many numbers between 110 and 148, 49, 45. So we write 111, 112. We can write ellipsis, and the last number 145. Okay. Okay, guys. So here we have until slide 13. Okay. Here we have some examples of set builder and roster rotation. I hope you understood this. And in the next video, we will see more examples. The slide 14, the complement of a set, and some examples of that. Okay. Okay, guys, so I hope you understood. If you have any questions, just let me know in comments, or you can check more YouTube videos. Okay. And here in the slide 13, you have more examples to practice. Okay. Have a great day. See you later.